All right, perfect. So we are recording. All right, yeah. So we have some of our team here in the engineering quadrangle here in Princeton. Maya, down there on the corner of your screen, she's our recovery sub-team lead. She's zooming in from her dorm, and then we have our mentor and flyer record, Michael Infante, zooming in from good old Puerto Rico.
Oh, good afternoon. Hi.
Hi.
All
The
right.
only thing you can
So,
jump in.
what would you like from us?
Okay, so the intent of this review is to basically give Ezra a good feeling that your team is close enough with the completion of the rocket to be successful at the Cup in whatever it is, 6 weeks, right?
Mhm.
5 or 6
Yep.
weeks. So what we'll normally do is you'll have a mobile camera and we'll walk through components of the rocket.
Yep. So I've got the
So
camera right here. So wherever you want to see, we can show you.
Okay, so I reviewed your report too in detail before the meeting in preparation for this, and I do have a couple of questions
Yeah.
about. Okay, the first thing is, and I missed this in the first report, my mistake. The effective rail length that you used in your simulation is set to 17 feet. And that is the length of the Ezra rail. The problem is that the rail doesn't have any effect on the rocket after the second to the top rail button. And
Yes.
in your
Yes.
case,
Yes. Yeah. So
okay, so
we changed that for the second report. I believe we fixed that. And if it wasn't fixed in the second report, it's been fixed now in our simulations.
okay, so it wasn't fixed for the open rocket model that I got in the second report, and that does reduce your rail velocity. So I'm showing a
Yes.
rail velocity with current button placement at just over 96 feet per second.
Hmm. Yes. Also to note is that that was with the old motor. With the, as you know, we had to replace our motor. Our newer motor is accelerating us faster. So now we're leaving the rail at, I believe it's like 120 feet per second. I can get you an exact number if you would like.
Nope, not necessary. You recognize the problem and you got it.
Okay, perfect.
Um, Next question would be the status of your motor hardware and the reload.
Yeah, so motor hardware, it's all being shipped to Spaceport America with Animal Motor Works. So they have it all taken
Okay,
care of. We've had it confirmed that they have the physical motor, they have all the hardware. So we're going to be installing it there at the field.
and you have the reload.
It's not a, I don't believe it's reloadable motor. Are you talking about like
Well,
reloadable like casing?
okay, so the O motor has motor hardware, which is the case, the forward closure, the aft nozzle retainer, and the nozzle.
Mhm.
When you buy a motor like the O, I think you're using an O 5800, you
Yeah,
get
the
the liner, the
05500.
grain, you get the liner, the grains, and typically the O-rings. And maybe with a CTI, maybe the nozzle. The smaller model, she gives you the nozzle, but that's separate from the motor hardware.
Yeah.
The
We
hardware is all combined with our purchase with Animal Motor Works. They just
yeah.
have it all there for us.
Mm-hmm.
Okay, so you're getting it through Robert DeHate, and so
Yes.
Robert has your motor,
Yes,
the
you're
whole thing.
correct. Yeah.
Okay, good.
We did the
Um,
same thing last year, so it's basically the same process with them.
okay. Um, I noticed from the open rocket model that the boat tail extends significantly beyond the aft edge of the nozzle on the motor.
Hmm.
Is the internal shape of the boat tail an extension of the divergent cone in the nozzle, or is it effectively a hollow structure providing just aerodynamics?
I believe our plan is, so the boat tail's not machined yet. We're actually planning to do that next week. But I believe it's going to be hollow. Simon, I know you were talking about it, but yes, it's going to be hollow.
Okay, have you ever heard of the Kirchner effect?
Not specifically.
Okay, so you probably should look it up.
Okay.
Kirchner effect is an effect where the nozzle exit plane of the divergent cone is recessed within a motor tube. That causes a vacuum to form around the nozzle and a recirculation of exhaust gases. And depending on the extent, it can significantly reduce the effective output of the motor.
That makes sense. Yeah.
So the way you would handle it, one way to handle it is to have the internal shape of the boat tail. Well, the way most people do it is that the aft plane of the nozzle is at the aft plane of the boat tail. Then you have no issue. If you recess the motor, you can drill vent holes around the boat tail to allow to avoid creation of a vacuum inside there.
Yep.
Or you can shape the internal surface of the boat tail as an extension of the divergent cone of the motor. Now, there are some limiting factors there because your efficiency goes down if that's too long.
Yeah.
And you're going to be pretty long in your case. But anyway, it's Krushnick, Krushnick effect.
Okay. Yep.
Can,
we'll look into it and we'll definitely take care of that.
Okay. And a normal dual deploy would switch the location of the drogue and the main from where you have it.
Mm-hmm.
I'm not suggesting you do that on your project, but be aware if you don't, if we think about this and if you don't, let's say you get the nose cone off, but for whatever reason you don't deploy the drogue, the rocket's going to go nose down and go ballistic.
Mm-hmm.
And if you split it where you're first at apogee, where you're currently splitting at main, then you have basically two large segments. The aft end will typically want to go nose down, but the other section is going to be fluttering because it won't be stable in a particular direction. So that is a safer configuration with respect to a failure during drogue deployment. So it's something to bear in mind as you design these large projects. Don't go switch things for your current project.
Okay. Yeah.
People do deploy the way you are, with drogue at the front, main in the middle. It's just less prone to failure if you switch those.
Yeah, that makes sense.
You have 37-foot shock cords.
Yes.
Okay, where along the shock cords is the drogue attached and the main?
So Maya might be able to go more into this, but if Maya, you might have the specific numbers because Maya's in charge of recovery, but it's 2/3. It's a 2/3 split. So it's 1/3 of the shock cord is, I believe it's nylon and the other 2/3 are Kevlar. And where they meet is where the parachute is. Maya, if you have any corrections, please just chime in.
No, I think that's correct.
I didn't see any mention of the nylon in the shock cords.
In the second
never mind.
progress
Yeah, it's
report,
there.
yeah.
It's there, sorry. Okay. So you want them Maya, you want them asymmetric like you have them, so good. Drogue deployment. I'm going to assume that the CO2 cartridges are not in the nose cone, but they're in what you call
the payload bay. Yes. So this actually right here, this is the bulkhead these are the two CO2 cartridges. So the CO2 gets loaded here. This is on the payload bay side, and then the CO2 is ejected this way, and this is just swapped the wrong direction. We have to screw this back on the other way. But the shock cord gets put on this eye bolt here, and then there's an eye bolt in the nose cone over there that it connects to.
Okay, let me see the eye bolt again.
Yep. And so as I said, we have to swap the direction here. This is actually going to be on this side. I just screwed it in the wrong way. But once it's screwed in, we're going to Loctite it and make sure this thing's not moving.
okay, you can't use that eye bolt. You can't use bent metal eye bolts. They need to be forged.
Okay,
And
that's fine.
the reason is that will open up under shock load. And
Okay.
you will lose the shock cord out of there. Just go to McMaster and buy the same diameter. Those look like
These are
maybe
5/16.
3/8,
These are 5/16.
5/16, and get a 5/16 but forged.
Okay. Yeah, no problem.
All right.
Well, we were already planning to put in. We have a few more. So we actually made a Home Depot run earlier today to get a few more nuts and bolts that we didn't have and they were out of stock. So we were already planning to make a McMaster order.
Okay. So back to my question. So you're going to push. So the drogue is in the nose cone. And You're going to push the nose cone off, shearing the shear pins with the CO2 charge.
Yes.
How do you get this? How does the drogue come out of the nose cone?
Well, with the nose cone, it's attached. The drogue is attached via shock cord, and the amount of CO2 that we have both a main and a backup CO2, and with that amount of pressure, it should pop off and pull out with the nose cone.
Okay, so should is really not a plan. Have you tested that on the ground?
So we had a ground test on Thursday. We ran into a few complications with the mounting mechanism. So we weren't able to test, but we're testing next week again.
Okay, so the way that you have the CO2 set up, it's going to have a tendency to push the drogue further into the nose cone until the nose cone comes off of the airframe.
Fully,
And
yeah.
then you're counting on the momentum of the nose cone and lower friction between the drogue and the nose cone, for the nose cone to basically pull away from the drogue as the shock cord extends completely.
Yeah, and I do want to be clear that the drogue is not friction fit into the nose cone. It's very loose in there. Like it's not really tight in there. Can I grab the drogue right there? It should be in that box. Take it. So we're gonna have a deployment bag to protect it from any charges going off. And then this is the drogue right here. It's a 3 or 4 foot. And this fits very comfortably loosely in the nose cone. So at least me personally, I'm not very concerned about it getting friction fit into the nose cone. There's just not enough room for that to be an issue.
Okay, you need to make sure you ground test all of it,
Yes.
right?
Yeah. Everything will be ground tested. We have students on campus over the summer break too. So as I'm sure you know, we have finals coming up. So right now is kind of a crazy hectic time, but we have students on campus doing finishing things up over the first few weeks of summer. I'll be making trips. I live 45 minutes from campus, so I'll be making trips on the weekends, and we'll be testing one of those upcoming weekends.
So to whomever did the CO2 charge calculations, nice work. And I also like the oversizing for the backups. So I'm flying one in September that has a 45-gram primary and a 60-gram backup. It's a big rocket.
Yeah.
That's the first stage. The second stage will be smaller. Okay, those are my questions and comments. So I guess the only real thing come out of this would be look up the Krushnik effect. Think about if and how you might want to address that in your boat tail design.
Mm-hmm.
And then if you decide you're going to make it, solid with an exit cone that matches, with an internal design that matches the exit cone, watch what that does to your mass, because you're turning that out of 6061, right?
Yeah, so the plan was that was the original plan. We were thinking to conserve mass, we might switch to fiberglass and make it hollow, and then in order to prevent that, we'll do some vent holes. What the possible plan is essentially buying a second nose cone and just cutting it down to where it tapers.
Sure, that's actually, they make transitions from nose cones where they have a problem in the manufacturer and it's not good enough around the tip. They just cut them off and use them as transitions,
Yeah.
and they charge us the same amount. The UTD team, I think they're going to write a paper on this, but what they're doing for their nose cone and their boat tail is they're 3D printing a structure that is the fiberglass thickness smaller than their final nose cone or boat tail. And then they're laminating on top of it.
That's interesting.
Which uses, so that the interesting thing about it is that the fiberglass or carbon fiber, I guess they're using carbon fiber in their case, provides the structural integrity you need and the lightweight. Hard to work with from a manufacturing perspective. You know, you build two half molds and then you got to join it, you got to do all that crap. Good thing about the 3D printing is it can give you the shape you want, but it has no structural integrity with respect to what we're trying to do in the rockets. But if you combine the two, you can use the manufacturability of the 3D printing with layup of the fiberglass to give you the strength you need. And that might be something you'd want to consider because you could get exactly what you want out of it instead of having to settle for what you can get in a transition from Wildman.
Commercially, yeah.
Wildman also, his fiberglass shop is down the next 2 weeks. So he won't be producing anything. Yeah, I've got 2 weird body tubes plus a coupler that he's owed me for 9 weeks now. I guess I'll wait 2 more weeks.
Yeah, we purchased all of our tubes were purchased through a Mad Cow, actually. So well, I'm gonna look on their website tonight and see what they're offering.
Yeah, okay. So make sure you push, then you have to get your transition for Mad Cow because I wouldn't count on Wildman stuff exactly fitting Mad Cow tubing or the other way around.
Yeah, yeah.
Okay, let's see the rocket.
Yeah. So you can see my phone camera, right? So this is our can you see this?
No, we can't. Oh. Yeah.
Yeah, can you make that, can you share that as a primary?
Let's spotlight for everyone. There we go.
Oh, there we go.
Perfect. All right. So this is our lower stage here. You can see we've got all the fins epoxied in here. This is the carbon fiber. We're doing the carbon fiber layup tomorrow. But here's a lower stage. Motor should come to about here or so. Here are some shear pins. This is just for our test. And then this ends up connecting to avionics bay. Right down here is avionics bay. So here's our black powder charges. Right here, our charge canisters. Those are 3D printed. And we have tested that, and it does hold up, which is good. We're going to replace this, as you said. Coming up here, this is our payload bay. So if you look in here, you can see the metal rods that are extending the payload. That's what everything's going to be mounted on. So the avionics bay and the payload is mounted on there. Right here is our payload. So they're mocked on some smaller rods right now, just as they work on them. But we have a CamSat here, which will have these Max IQ avionics, and then this will be some sensors, and then we have a third CubeSat configuration, 2-unit CubeSat that's going to sit right here. It's on the so, right here is our avionics bay. So this is our new one. This is the mock-up that we made out of PLA. And this is all of the electronics mounted to it. This is just a much nicer version that we made out of nylon that's actually going to fly. We just haven't been able to put all the components on it yet, so that'll be happening probably later today. And then, as you saw earlier, it's right here. This will sit from payload bay. We go into nose cone. These mount at the end of those metal rods, and this is where the CO2 sits. And then drogue chute will sit right in here. And then right here's the nose cone. We're gonna have the nose cone bulkhead will probably end right about here.
All right, you guys are quite a ways along. Do you have the aft centering ring installed in the
Yes.
fin can?
Yes. So here, can I get David? Can you come over here and just put this down, just so we could show the aft? Here we go. So right here we have the tube centered in there, and then this centering ring is right here. We've got 3 centering rings that run all the way up the tube.
Okay, how are you doing retention?
We
Motor
have
retention?
our motor retainer right here. So once we get the boat tail set, and then we have this last centering ring that we're going to merge with the motor retainer and have it slot on. Yeah.
All right, so now I'm not seeing how your boat tail works.
Oh,
Simon,
yes.
yeah, do you want to explain?
Yes, so basically there is space between this and the last like centering ring where we can basically like stick the what's it called, the boat tail on. And then this right here is how we're gonna install the basically the retainer rings, but we're able to shave off enough of this. There's enough space between this to be able to shave this off. So we'll do that on a lathe. And then there will be enough space for us to attach the boat tail through here. So if you
Okay, so the boat tail is the last piece installed.
Yes.
After the motor gets in and the retainer ring it goes in.
Yes, that is correct.
Yeah, you're going to have challenges with the gas expansion from the motor. So, okay.
yes, we'll look into that effect and see. Most likely we'll go with the vent hole option, but if there's like something more interesting and we see some strategies on the forums, then you might try to use those as well.
Okay, so it looks like you might have fillets on one fin, but not on the other
yes,
one.
they need to be
So we
cleaned
have
up.
fillets on all the fins. It's actually just this one specifically that needs to be cleaned up. So we gotta
Yeah.
do one more layer.
Mhm.
But the rest of them are looking pretty good here. We've done two kind of sessions so far on the fins, and we're gonna do one more. Like I said, we're gonna be working in the composites lab tomorrow doing the carbon fiber layup. So when we do that, we'll also fill in this last fillet.
Yeah, because you need to fill it in there before the carbon fiber because of the bend radius of the carbon fiber.
Yeah.
Okay, can you show me how one of those pieces is going to be laid up?
The carbon fiber, yeah, sure. So we have 3 layers. So we're gonna have one here, Simon, if you just want to hold that. Yeah, here. There you go. I'll put Maria on the camera. So we've got a first layer here, then the second layer, which
Thank you,
goes.
Maria.
Yeah, we've got a second layer that goes 2/3 up, and then we have a third layer that will cover the full fin. And we purposely made it extra long so that we can bond them together, and then we'll sand it down and give it a really nice finish.
Okay, good.
And something to note about these layers is they're all in different orientations, so they take the forces in their different orientations. This is at 45 degrees one way, this is at 45 degrees the opposite way, and then this is at 90 degrees.
Yeah, that looks good. I mean, with those in your documentation, it said 3/8 G 10 probably for the fins.
Yes.
So those are 3/8 fins,
Yes.
and it's through wall construction with good fillets against the motor tube and the airframe.
Yeah, so these are through wall. These go all the way to the motor tube.
Okay, so you're only going about Mach, what, 1.17 maybe?
Yeah, I think highest projected with the new motor is 1.81.
Yeah, continue your path, but that's robust enough. If you made those fillets a little bit bigger, you wouldn't need the carbon fiber.
Yeah, we figured, we have the material, might as well. Just as a safety precaution. I know we were there last year. We saw a few fins shear off. Um, I'm not afraid of anything shearing off, but we had it. We said it would be good experience one way or another anyway. And then it also looks really nice too at the end of the day. So
Yeah, you'd never be sorry for doing it.
yeah.
Okay, let's talk a little bit about your test plan. Where are you on that?
Yep. So here, do you still need the camera or do you want me to switch back to our main visual?
No, you can just switch back.
Okay. Yep. Give me 1 second.
You guys are, based on where you are, I'm quite confident you can get the rocket looking finished and looking great by the time you get to the cup.
Awesome. Thank you. Yeah, so our test plan over the next month or so, as we finish the last few things up, we're going to do our full system testing, which is our recovery systems. And those are recovery systems that are being triggered by the avionics. So we can remotely trigger the avionics using computers. So via the radio frequency, which by the way, we do now have the amateur radio license, so we're all set to go there as well. But yeah, that test will probably be within the next 2 to 3 weeks. There's funnily enough, my cousins live about 10 minutes off campus, and they have a massive backyard, and they volunteered their backyard for our ejection testing. So that's our test site because we're not allowed to test on campus just for safety regulations. So that's where we go, and then we'll do both the main backup for both our drogue and main parachutes. Just test through the whole system, make sure everything fits, all the shear pins break, and after that, we should be pretty good to go.
All right. I think you guys are going to do fine.
Awesome. Thank you very much. I appreciate it.
I hope everybody gets through finals, right?
That's the goal. Yeah.
And then I imagine that you're going to paint it beautifully, right?
Yes. So we're hoping we can get all the carbon fiber done and everything by next week so we can paint it before we leave campus. We have one team member who his entire job this year has just been working on the livery and the logistics of all that stuff. So we want to get that done before he leaves campus for sure.
Okay, so correlation, not necessarily causal, but the better a rocket looks, the higher the probability of failure. That's just statistical.
So you're saying we shouldn't paint it?
Yeah, we just won't paint it at all then. It's okay.
Well, I've got a lot of teams doing their test flights naked. Just fiberglass and
oh yeah,
however it looks. Okay, so let me talk a little bit about the cup. So how many of your team were there last year?
So last year it was 3 team members plus Michael. So we were the smallest team there. This year we've had a pretty good expansion. So we're bringing 14 team members plus Michael. So we'll have 15 in total, which is really exciting. A majority of our team is flying in. So we're actually flying into Phoenix Airport. And then we have 2 rental vehicles that are driving from Phoenix to Las Cruces. And then they are departing out of El Paso at the end of the cup. And then 4 team members are making the cross-country trip, driving from Princeton, New Jersey to Las Cruces with the vehicle and all of our supplies.
Okay. So are the three that were there last year on the call?
It was just me. I was the only one on the team that was there last year.
Okay, so it was just whether I phrase this to compare to last year or just because it'll be new to the other, I guess 13, you're bringing 14, if I remember your report right?
Yeah.
So last year, Jake, you'll remember that there was this big line to get into safety inspection. But before that, there was a big line to get into registration.
Yeah.
Not happening this year. So when we open the convention center on Monday morning, and I expect that to be probably 8 o'clock, teams will be able to go directly into the hall from the southwest entrance and set up your table and poster session, do all that stuff. Registration will be one person from your team.
Oh,
team
awesome.
lead, and it'll still be in the ballroom, but you won't be waiting out in the sun like last year.
That's fantastic to hear.
When you finish registration, you'll remember that for safety review, everybody was lined up waiting to get in there. Well, that's not happening this year. When you're ready for the safety review, one person will go to a sign-in desk, sign in for the review, and get a pager. We bought a pager system to use this year. Then you can go back to the pits. You can mingle with the other team members. It has a range of 2 miles, so you could probably go get lunch. And when you're up for inspection, when we have reviewers ready, you'll get paged. You bring your rocket, whatever paperwork you want to bring, your team members, and go right into inspection. So no waiting in the hall.
Awesome.
Then when you get to the VLA, you remember the inspection, the line for final inspection. No more line. When you're ready, you'll go to a designated place and you'll sign up for final inspection and you'll get a pager. When it's your turn to get inspected, you'll be paged. You come up, you get it's Harry who ran it last year. He'll do the inspection. We'll impound the rocket at that point. It'll be covered in shade. And you guys can go back to your, well, when you're ready to launch, you go to another place to sign up and you get a pager. You can go, lunch, do whatever you need to, go back to the tent. You don't need to be hanging around waiting. You'll get paged when we're ready to send a salvo to the pad. You'll get your rocket out of impound, go straight into a lane to go to the pad, and the whole group will be released at once. So right now I'm anticipating teams, that whole process, probably 20 minutes.
Awesome.
And it won't be sitting around. It'll be get your car in line, get your rocket, get ready to go. And you'll be pre-assigned a bank on the solids pad. So remember last year we had 3 banks. We're running 4 banks this year. And we will be putting the O's on bank D. So I already can tell you right now, you're going to be on bank D.
Awesome. Cool.
We might actually launch you from the 2-stage pads.
Okay.
But it depends on how many people are ready to go. We're providing tents. So we're putting up, we've spent a lot of money to bring in a group from El Paso with basically circus tents. They're 40 feet by 200 feet. And I think we have 8 of them. And these are big, heavy, wind-resistant tents. And we're providing tables. So all you'll need are some chairs, if you want them. But you won't need to bring that kind of stuff. You won't need to bring an easy up, and you won't have to worry about the wind or anything like that, or any of that setup. We're handling all that for you this year.
Okay, and at each spot, how many, is it 2 tables per team?
Yeah, I don't know.
Okay.
I don't take care of that part of it.
All right, no worries.
It's probably an integer less than 10, greater than 1. And it might be a prime number.
Good to know.
No. Last year we had some wind closures, and we were required to use a weather station at the HLA, which is about 5 miles away. This year, we've bought weather stations, and we will have a weather station at each pad bank, and they are publicly available. So you will be able to log into a website and see exactly what the environmental conditions are at the pad bank you're going to launch from. And we're in the final stages of publishing, of reviewing, actually, better word, the safety plan, and I'll be distributing, as RSO for the event, I'll be distributing the guidelines under which we're working for wind and cloud closures. It's basically the same as the TRA code, except our max ground wind speed is 18, where the codes is 20.
Okay.
We will also have an upward-looking LiDAR that is purported to give us the wind profile to 100,000 feet, where we haven't seen it before. It's being brought in by one of the big aerospace companies. I don't remember which one right now. So this year, we're just kind of looking at the data to build a set of guidelines for using it potentially in the future. But it'll be interesting to see. Other than that, we'll be opening the launch at 7 a.m., the launch line. So we'll be flying at 7 a.m. and we'll go until wind cuts us out, or probably 5 p.m., my guess. There may be one day where we're closed earlier because the Juneteenth holiday is one of the days during the week. And there are government employees both at White Sands and at Spaceport that get the day off. So we may not be able to run a full 14 hours.
Okay,
or
and
10 hours.
when does the VLA open? Like, when can we drive
we'll
in?
be at latest is 5, probably earlier than that, because we're moving the launch, the waiver open up earlier. So we'll be ready to handle teams by 6 a.m. And that would be final inspection and then queuing for the first salvos to go out. Now, this doesn't affect you guys, but this year we're going to be allowing, at least this is the last word I have, we're going to be allowing a limited number of team members from hybrid and 2-stage projects to camp at the VLA. Because I want to try and keep them off the roads at 2 o'clock in the morning. And since I'm mentioning roads, you know, the road from the highway, the main highway back to the VLA, that 2-lane road.
Yeah.
Observe the speed limit. No speeding on that road. It's not conducive to high speed. We don't want anybody to have an accident on that road. Can't think of any other news. So we've gotten a lot of feedback from the students, and we're trying to incorporate that into improvements in the event. Of course, you'll have the live stream for any team members that are interested that can't get out to the event. And we're doing a lot of work on that actually now. So graphics are a little better and coverage will be better.
Awesome. Yeah, I mean, it sounds like you guys are putting together a great event. So we're really looking forward to it.
Well, we're trying. This is the largest event of its kind in the world. And we have 130, I just checked, 136 teams as of this afternoon, still coming to the event from around the world. Well, excluding communist countries. Okay, do you have any questions for me?
I've got nothing. Anyone here have any questions? We're all good. Michael, if you have any questions, please feel free to chime in, but otherwise, we're ready to go. We're looking forward to it.
Okay, good. So you got to pass a link to Ezra for how to upload the video from this review.
Mm-hmm.
And my last thing is I'll just reiterate, rockets looks like it's coming along well. The stuff you've done to date looks excellent. The build quality, where you're headed, looks really good. And I am fully expecting a successful flight.
Awesome. Thank you so much, Ken. I really appreciate it.
All right. And I hope you guys, whoever was a TRA member, voted in the election for new board members, because I'm running. So the polls are still open, but you have to have been a TRA member the 1st of April.
Might be only me, but I'll take a look. I'll put your name down.
Every vote counts. So vote early, vote often. Remember, everybody going downrange, it needs to be a TRA member. Okay.
Yeah, we're gonna get every team member to have TRA. I'm gonna send out a message this week, and we're gonna try to do the pre-registration as long as we can get all the documents in by Friday.
Okay. And there's a lot of stuff that goes around about the environment out there. It's going to be, well, likelihood, it's going to be glaring sun, 100 degrees in the shade in the desert. So wear good shoes, good foot protection, long pants, long sleeves, hats, take care of yourself. We had a couple of students last year that ended up in the med tent for dehydration. So you'll hear my message very consistently being first thing at the Flyers meetings, bottle of water, drink. You won't believe how fast you'll dehydrate out there in the desert. Jake, you know what it's like. So
I do.
Make sure
it was hot.
Make sure everybody on your team is ready.
Yes. Yeah, and we've got hats being made and the long sleeve SPF shirts. Made sure they were white so they weren't taking up too much heat. So
okay, and remember that there is a border checkpoint between Las Cruces and the turnoff to Spaceport.
Yes.
So you should be fine. They've gotten to kind of expect a bunch of rocket people going out there, but just don't be surprised. They're pulling all the traffic off and running them through detectors.
Yeah. Okay. No problem. And we have a few international students, so we're going to make sure they have their visas and everything.
Yeah. Make sure they have passports.
Yeah.
And when you're returning and you're going through Passport, El Paso, follow the signs, don't get into Mexico. We had a team a couple of years ago coming from Albuquerque, and somehow they drove into Mexico, and I think they were carrying their rocket and maybe the motor. And you might imagine getting back across the border into the US was problematic.
Oh gosh. I can imagine. We'd rather not be there. So
yeah. Okay, so you have my email. Contact me if you have any questions, comments, anything you want. Just let me know. I'm here to help. My job is to get all of the teams flown safely. So we'll get you off the pad. I want to get you through the safety review with no remediation efforts, like those eye bolts.
Yeah.
All right. I should ask, what are you using for, how are you attaching the shock cords to the eye bolts?
Last year we had the alligator clip, or not alligator clips, the clips. I can't remember the name. Yeah, but we're not gonna do that this year. We're just gonna tie them. It's just a lot easier and safer. Not tie like a knot, gosh, do I have a shock cord here that I can demonstrate? Last year we were using clips and we got in trouble at the safety review. And so we ended up having to loop it through the eye bolt and then through itself.
Okay. You will still, that's the way I do mine.
Okay.
But you'll still have a connection point somewhere. And if you haven't gotten your quick links, look on Amazon for soft shackles.
Soft shackles. Okay.
And you don't need the big ones. You could use a soft shackle, a double wound soft shackle made out of 6mm Dyneema, has a breaking strength of 24,000 pounds. And they're light, they're small, they're soft. They don't take up much space.
Okay, great.
Just the smaller ones. But you could use quick links if you want. Just be careful, because if you're down, you know, if you got a 1/4 inch, that's your weak point in your recovery. And somebody will say, well, you've got this big rocket. How did you decide to use that size quick link? So you need to be ready with whatever documentation you have or simulation results, right, when you go into the safety review.
All right. Sounds
Okay.
good. Yep.
All right. So I don't even know what time it is. Hey, look at this real quick. We're early. So just make sure we post the video, and I will see you guys in Las Cruces.
All right. Awesome. We'll see you there. Thank you so much,
All right.
Ken. Have a great weekend.
Thank you.
Yeah, and Michael, thank you. Thank you for mentoring the team.
Thank you. Thank you.
We'll see you
Take
guys
care.
later.
Bye-bye.
Bye.